Welcome to Glance Livestream number 4. I'm Robbie, and I'm working on creating a visual programming language for Haskell. So let's start by looking at the current state of the app. So you notice a few things are different. These nodes have 3 boxes. They have the number and then the name of the node. So these are all apply nodes. And now you can connect the nodes with wires. And currently there are no restrictions, so you can have multiple connections going in or out of a node. And you can even connect ports within a node to each other. There's also zooming and panning. Panning's with the space bar and then the mouse. Zooming's just with the mouse wheel. And undo still works. So that's the current status of the app. Let's see, let's go through the code. I'll show what's changed. So I'm in the middle of doing a bit of a refactor. So previously, all the code was in main, and so I split this out, and I've put all the GTK code into GTK GUI. And then basically the rest of the code is in GUI internals. So notice GUI internals doesn't import any GTK or GDK things. Oh, yes, also, if you have any questions about Haskell or programming, happy to answer your questions. Okay, so the way panning and zooming works is that there is a transform, which is simple. It just has a scale. This is basically the zoom factor, and a translation. And so the node positions, or the element positions, let's go to element. So these positions are in element coordinates, and so these positions do not change when the transform changes. And so when you draw an element, the position is calculated by applying this transform. Similarly, when you have the mouse position, so let's go back to the app. So basically when I zoom in or when I pan, the element locations for these nodes doesn't change. And so now let's say when I'm dragging a node, I need to translate the mouse position, which is in window coordinates, into the element coordinates. So I basically do the inverse of the transform to do that. Anyways, so that's zooming and panning. Then for port connections, we have this. So I've split out basically functions that relate to a node into this node type, sum type. And so basically you'll have a node type for each type of node. So like an apply node or a case node, or maybe an if node, etc. And so this is just a plain data structure here because I want to enable a user to be able to add new types of nodes while they're using the app. And so if you're familiar with Haskell, you might think, well, this should be a sum type. The problem with that is that sum types are fixed in size, and you can't dynamically add new variants to a sum type. So instead, we'll just basically have a set of node types, each element. So let's go to... So each element carries with it a structure that contains its node type. And the idea is, theoretically, each element could individually modify its node type, but these will probably be shared amongst like all of the apply elements. So the idea is these node types are essentially constants once they're created. Anyway, so let's go through this. So it has a name. So for apply, this is apply. And it has information about like how many ports it starts out with. And, as you, let's say, you have an apply node or let's say a case node, the number of ports can grow or shrink as you add or remove connections to it. And then we have various functions that are used for drawing the node or figuring out where its ports are, how big it is, etc. And so these are just, a bunch of functions. So you can sort of think of this node type as sort of like as a class, and then these are its methods, and then, here are some constants. It's all at dynamic, all at runtime, so it's not quite the same as like you'd have a object in a object-oriented language. This is really more like just how you do it in C with function pointers, essentially. Anyways, so the way the ports work is that we have functions like this port clicked function, which will you give it an XY relative to where the node is. You say which element was clicked, and then they'll return which port was clicked. And similarly, the draw function, let's see, yeah, we have port locations. Anyways, you have things that figure out where the ports are. And then the actual edges are in the app state. And so the edges are pairs of ports. And this port is a element ID, so which node the port goes to, and then which port in that node is the edge connected to. And so the rendering function goes through these ports. It calls those functions, which we just saw, that figure out where the ports are, and then it draws the edges. So let's look at this. And so for each type, there's a specific function that will draw it. And so this is just drawing the boxes. Notice we use the transformation to sort of manually scale everything. Hopefully, I haven't looked into Cairo too much. Hopefully there's just a simple way to take one of these, sort of like a whole Cairo diagram type thing, and then scale the whole thing. So draw line is what's used to draw the edges. And so that's done with this function draw edges. And so we're just drawing a line between the two ports we had. So fairly straightforward there. And I think that's, oh yes, and so then also when you click on a node, it has to figure out whether you've clicked on basically, if you click on the name of the node, I call that the handle, and that's the part you click on in order to drag the node around. And then otherwise, if you click on a port, then it has to know to start drawing a line, start drawing the edge between that port and the mouse position. And then once you click on another port, then it'll release. So I'm clicking, nothing's happening. If I click on the port again, I think that will actually create an edge from the port to itself, which maybe we should get rid of at some point. Anyways. And then the rest of it is pretty much the same. I haven't changed undo, which I haven't added the edges to undo, which is on my to-do list. Okay, so I'm in the middle of doing a refactor, which is getting all of the non-GTK stuff out of this GTK GUI file. And so the idea of this is to reduce as much as possible the interface with the GDK/GDK code, so that one, it creates like a smaller, cleaner interface that's hopefully easier to understand. So that way more of the code is just non-GTK, non-GUI, non-GDK, and so that way someone, if you want to come in and change something, you don't have to be thinking about like, what is this GTK stuff that's happening. And then the other reason for doing that is that if in the future I wanted to use a different front-end framework, like do a web app or use some other GUI toolkit, I just need to replace the code, in this one file, and then everything else should work theoretically. So I've gotten about halfway through this refactor, and there's still more to do here. So what I'm looking at now are the click actions, and so this is split up into a left click action and a right click action. And these both take a GDK event button. So I want to not do that. And instead, these should just take a mouse position. Let's make that change. So the first thing I'll do is copy this code. And I'm going to put this code in the caller. Window element, window to element. I'm going to get the raw mouse position. Well, let's get the actual mouse position. So the state is in a IO ref, so I need to get that. Okay, so now we're going to replace that with mouse position. And so these don't compile, which is expected. And we will change this to a tuple of doubles. Okay, that still works. So since I moved this, looking up the transform for the mouse position into the higher function, I don't need this state ref. Or I don't use this state ref anymore. I might need it in the future for right-click action, so I just put an underscore in front of it to tell the compiler to ignore the unused parameter warning. Okay, so now that that's done, I can... Basically, I want to take all of this code and move it all the way into GUI internals. Let's put this somewhere. So I should add some sections to this, or maybe split this up even more, because I want to sort of split this up into callbacks and things like that. Let's put it... Okay, so now let's see, mouse button. Now let's split this up. So I'm going to split this into two functions. One that's the callback, which does the GTK stuff, and then another that does not do that. or that doesn't have the GTK stuff in it. And so all this will need to do is it needs to get the mouse button and and it needs to get the raw mouse position. And then it will call background press. And then finally we have GTK event stop. And so now this will take the mouse button and the raw mouse position. Okay, and I need to change this type. So a mouse button is a type that I created, and the mouse position is just 2 doubles. And this will just be IO nothing here. Let's see what it's complaining about here. Ah, those are not in scope. So this I will move over to GUI internals. And I do need that mouse button type. So let's export background press. And I need the mouse button type. Okay. Let's see. Window to element coordinates. Let's see, where did I call that? Ah. feel like this should go where the transform is. Ah. So I need to update this to background press callback. So I'm using Ormalu for formatting, so that's why you noticed it jumped like that. Okay, and so that works. So I've extracted the button press, the mouse click code. So notice how little code's actually in here. So it just gets the mouse button, it gets the mouse position, and then it calls this function. And that's all it does. Okay, so now let's look at this. To mouse buttons. So this is GDK specific. So that needs to stay in here. This is also GDK. And I've already extracted the background, the timeout callback, into this step function. Let's see, add undo input action. So this looks like it should not be in here. Since this doesn't use, this is just using normal Haskell code. Same with this. Okay, so now I need to do the same thing for the key press and key release callbacks. Okay, so let's look at the inputs. The only input here is the event key. And we get a key. Now, I haven't really abstracted these keys into anything. And this is sort of hacky, like I don't think this is the proper way I should be doing key presses. Since control, like instead of control Z, I have /sub, whatever that means. So I think what I'll do, Okay, so let's look at this code. So here's Control Z or Control G is pressed. And then otherwise, okay, so this is for if I'm holding down the space bar, which is the translate key, is space. So then I check whether let's see, in translation, check whether there's a translation. That didn't work. Oh, so why is that a maybe? Seems like there should always be a translation. That's strange. Oh, if something, a translation is currently occurring. Okay. Anyways, so that means that I should start panning. Let's see. So there's sort of two parts here. There's like specific key was pressed, and then there's other things happening. So the problem is these are sort of GDK specific potentially. Okay, so I think what I'll do here is I'll create a structure which will be either a specific key that was pressed, so like Control Z or Control G, so the key and then the modifier probably. Actually, I'm not sure if that's a good idea. The problem is that keyboards are complicated. There's a whole bunch of different character sets out there, so I'm not sure if I want to really encode all of the keys. I think it makes more sense to encode the actions here that we want to take. So notice that we don't actually, well, here we're just checking whether str is the translate key. And so, yeah, let's split this out into a struct, into an enum, which has the different actions. This code will just return one of those actions. Maybe if it's a string. So eventually I'll want to do like, you'll be able to type and then that'll go into a box. So we'll also need to have an option to just capture that character or the string potentially. But for now, I think just a simple enum should work. So I'll call this a key event. So let's see. we can have an undo key. Oops. And abort key. And also have a translate key. Okay. Let's comment all that out. So this might be if syntax you're not familiar with. So this is using multi-way if, since right, the actual keys should be configurable. And so that means I can't just do plain pattern matching on the string. And so we'll have to check whether that key string equals the key mapping we've configured. So if the string equals the translate key, then we return translate key. So I'll call this key event. That needs to be an let. And then we're going to have a function down here, which is, I'll call this key press, again, key press callback. And we'll put that code in here under our and so this will take a inputs ref, state ref, and the key event. This again we need to put in here. And this will return an IO of nothing. And we'll need to export that. Great. And does not like parse error. Hmm. It does not like this let, apparently. Oh, we need an otherwise. Oops. So I believe I did not. I need to export that. So yes, this code. Let's just copy this. Okay, so it's saying I don't have a redo key. We'll need to add that. No, that's not the... I do not have redo, I have abort. Okay. So this code should be good now. So let's put the otherwise case in. So that's actually a text. Okay, so this code looks okay now. Now I just need to copy in these actions. GUI internals, there's some errors. Okay, just needed to add some imports there. And code still works. Oops. It did not work because I'm missing a case for the unknown key, which I'm not going to handle for now. And I wonder why that's orange there. Okay, so undo works, redo works, and translate works. So everything's still working. Great. Let's make sure zoom works. Zoom works. Ah, it says, oh, let's rename that key event. Great. So just cleaning up the imports there. Okay, so now we're only at 200 lines of code for the GTK module, so that's great. Let key, line 100. Ah, So key could be a maybe, in which case, let's just call that an unknown key of empty string. Great. That's key press. Now we also have key release. Let's modify that too. So we have key release. Let's just copy this. So we're going to do the same thing as with key press. So now instead of a GDK event key, this will be a key event. This will be an IO of nothing. And won't have that. Don't have that either. And this will be a case of, so if the key event was a translate key, we do this. Otherwise, we do nothing. So we'll rename this callback. See if that works. Okay, we need to export this key release function. And so all this is going to do is it takes the key and we do case key of, or yeah, I guess we want this if again. So if the key is just translate key, then we do translate key. And then otherwise we do the unknown key. And we call key press inputs ref key event. Oh. Got messed up there. Okay. Because this should be key release. Great. Okay, and this is no longer Control Z or Control G. Get rid of that. Okay, so now our key release callback, all it does is it gets the key, it sees if the key is the translate key, so the translate key is space, so if it's space, then we return this translate key inu, and otherwise we do unknown key. This currently doesn't matter since our code's only checking for translate key. Then we call key release, and then we do GTK event stop. So everything still works. That's great. Now we're down to under 200 lines. Let's look at scroll. So again, let's rename this scroll callback. And so what are its inputs? We have inputs ref. We call this add scale action with the inputs ref. So the question is, will this like delta y change with different front ends? So I think for now, I'll just pass in this delta y to the internal function. So again, copy and paste this here. Rename this to scroll. And all we want here is this delta y. So that's going to be a double. And we need the add scale adjust function. Add scale adjust action. So let's clean this up. Oops. So I want to take this, move that over. And export this. And that still works. Great. Okay, so now notice that we have no modify or read or write IO refs in GTK GUI, so that's great. So that means we aren't really modifying anything. So now it looks like I think all of this should just be GTK, GDK specific code. Scroll and then start app is of course going to be GTK specific. Great. So there's a lot that I've exported here that I probably don't need anymore. So I'm going to comment all that out. So we need inputs and we need app state, of course. And we need translate key, empty app state. So this should be in here. Text, text, text. We need render Cairo and update background. and everything's working. So as you're drawing an edge, you can also move a node. So that's interesting. Anyways, great. Okay, so let's look at this API here. We have inputs, empty input, state, empty state. We have the mouse button type. We have the key event type. We have render Cairo. What does that do? Oh, okay, so this is doing some Cairo specific things. So eventually I'll want to also split off all of the Cairo, the output stuff, into its own module. And we have update background, which does all the drawing, and then we have our various callback functions. Background press, key release, scroll, and then this is our main step function that does all the updating of the state and the input. So I think this is pretty good as it is. I will commit this and update the to-do. And I think that will be all for today. So thanks for watching. And you can check out the code on GitHub, which is linked in the description. And this code is in the GUI folder.